Please give a big round of applause.
Hello, this is a very well-attended conference. Before I begin, I should explain, I do a lot of public speaking. I've learned that hot water helps me a lot. So from time to time, I'm going to reach for that and calm my throat down. I also like to learn more about the audience I speak to. So by a show of hands, how many people here are from within Korea, within South Korea? Wow, the minority? How many people are from outside South Korea? Okay, and the rest are from Mars. How many are from the business side of the community, and you're like business executive and program managers and so on? How many are engineers and technical people? So I can tune my talk. All right. Now, my talk is going to be sort of interesting in the sense that I want to divide up AI into the digital side and the physical side. So how many people here have like degrees in physics or electrical engineering? Okay, and the rest of you are computer science people? How many computer science? Okay, good. Prepare to be offended. Okay, I'm going to talk about the topic here is vertical AI, and I think in a place like South Korea, particularly Asia in general, I think people are already sensitive to the fact that we need to go vertical, and particularly in the industrial space. Some of what I say may seem intuitively obvious to you, if you're coming from here, but it's actually not very intuitively obvious to Silicon Valley, where I live, at all, because in the last 30 years, everybody and his brother has gone and taken computer science, where the easy money is made. But if you remember nothing else about my talk, hopefully you will take away my message that the next 50 years is about the physical world. Okay, so let me see if I can prove it to you. So the title is Future of Billions of Domain Expert Agents, right? The interesting thing here, to you who are already in the AI space, is not the word agents, but perhaps the word domain expert. So I'll talk about that. It's also known to me as the divide between industrial AI optimism versus what we call frontier AI, the big labs, what I call pessimism there, right? People worry about geopolitics, people worry about how AI is going to kill us all. And so there's a tension there. Allow me to sort of introduce myself from whence I speak. There's a relevance here. I was invited here as a board member of the AI Alliance. How many people are familiar with the AI Alliance? Okay, so maybe I'll share a little bit about that with you. Previous to founding this company, I was also the lead for industrial AI at Panasonic out of Osaka, and that was thanks to an acquisition of my earlier company, Silicon Valley based by Panasonic in 2017. Well, maybe you can relate to one of my earlier lives. How many people here have used Gmail? Okay, people are just not raising their hands. But I was the first engineering director of Gmail and helped launch Google Apps in the early days. Before that, I was also a professor. So how many people here are from academia? Okay, at least one. We're going to be talking to each other later. So we're former professors. Well, he's current. I'm former. I did my PhD in semiconductors at Stanford, and my undergrad at ECS at UC Berkeley many, many years ago. Okay. Just a quick word about the AI Alliance. We are a global technology collaboration, and I won't say much, but we are all about promoting open development, open science, open space AI, right? Not open AI, the company. And I encourage you to go to thealliance.ai and learn more about that. And I think open science, open development is very, very key to the future of development of any technology, particularly AI in Asia. So I spoke of the word AI pessimism. There was a survey done a few years ago, right? And the prologue to this is that you should know that there's generally an optimism about technology, particularly in well-developed country. So any survey that says, do you think this technology, internet, mobile technology is going to improve our lives, or is it going to hurt us? Generally speaking, people in the US are very optimistic about it, right? And when you plot the trend against GDP per capita, which is something I did, typically that curve goes up, right? Meaning high GDP would be very optimistic about technology, and lower GDP because people can't really take advantage of it as much, or it doesn't diffuse to these countries as quickly. People are less optimistic about it. But the inverse is true for AI. Okay? And we know the relationship is real. We can try to explain it, but the what is there, but the why is not clear, right? But you can sort of expect, there's a lot of debate in Europe, in America, and so on, about slowing down the development of AI before it kills us all, right? So there's certainly that aspect about the pessimism. There's also a legitimate pessimism about AI taking away jobs, right? Taking over not just over the world, but take my jobs and my livelihood away. So you see, somewhat surprisingly, for AI, this survey results in a very strong correlation in the negative direction. Okay. But I want to show you what I did was I took that and I took the same data, but I plotted against what I call the industrial content. Okay? So industrial content is you look at, how many people know like the size of not the size, but the composition of the US economy? How many percent of the US economy is in the service sector versus the industrial sector? Would you say 50% service economy? More than 50%? It's actually 80% now, right? Very, very high. And in a place like South Korea, Japan, China, Vietnam, and so on, it's a much higher percentage that is in the industrial economy. And so when you plot it versus the industrial percentage, the trend is strongly positive, right? You see Saudi Arabia, oil and gas, China, Mexico, India, and so on. Okay? And so you have to ask yourself why that's the case. But if you look at the global map, this is a color, the darker the color, the more industrial an economy is. And when I shared this a couple of years ago, it was sort of controversial. It probably still is, but I think it's coming in the last year to be the case, right? For example, as we all know, a lot of the open source models from China are now world leading, right? In terms of number of downloads and usage and so on. So the next thing I did, and you notice South Korea is also very strong in industrial content. And so I took this curve, right? Let me go back. And I plot the residual. Those of you that took math in school know that the residual is kind of like the extra or the extra optimism or pessimism that is not explained by the curve. Okay, it means the extra. And you look at this, right? Saudi Arabia, China, South Korea, United States is above their position on the trend line. And I thought this was really interesting and very coincident. And I did this analysis a year or so ago. But I also just heard about Korea wanting to become the top 3 AI power, right? And I think that's correlated with this extra optimism. Okay, so we'll see whether that's going to happen. I did also some modeling of this and just do a model that for an extra 1% of optimism above the trend line, what if that adds 0.2% to GDP? That's just a parameter that I chose. What would happen? And you can see the difference between the gray, which is sort of the baseline in 2022, versus what the future might be, right? So we can think of that as the return on investment as far as AI. So that explains a lot about the general optimism, and it sort of warns against being overly pessimistic. Of course, we have to build AI in such a way that there are guardrails, right? But to say that we're going to slow this down because it may kill us all or it may take jobs away, I think is a misguided objective. What we should do is actually continue to build, but build safety and build guardrails into them. In other words, it's how we build AI. It's not whether we build it. The world is also split, right, into what I call horizontal AI and vertical AI. I think of this audience as mostly vertical AI people, actually, whether you realize it or not. The horizontal AI are the foundation models, right? These are very large models that know a lot about a lot of things, but a sort of an ultra deep expert in not too many things or in nothing. And so what's going to happen is we have this horizontal AI, right, the LLM layer. How many people agree with the statement I'm asserting that LLMs are being increasingly commoditized? How many people agree with the statement that you cannot make money with LLMs? Yeah, it's true. All of the foundation companies, essentially there's a bunch of dynamics that we can get into, but essentially the revenue that these companies are getting versus the cost of serving the inference is completely upside down, right? So of course they know what they're doing, or they know what the problem is, so they're going into the enterprise. They're all going to building enterprise business models, whether it's OpenAI, Anthropic, X.AI included, Mistral, I just heard signed an agreement with ASML and so on. So the race toward the construction of vertical AI is inevitable, okay? What's in between is really interesting because you cannot just say, well, I can't make money with horizontal, I'm just going to go vertical. What do you need to have in order to go vertical? You need expertise, right? I think I came in a little early today and I heard some of the speakers talk exactly about what's happening in this domain. You need to have domain expertise. That's kind of ironic, right? In an age where we say all knowledge is inside the model, we say, no, actually, no, we need human expertise still, okay? And to resolve that paradox, what you realize is that the information available internet is not the sum of human knowledge. It is not. It is actually very small, right? In every company, in every process, in every engineering endeavor, there are domain experts. There are domain expertise specific to that task, to that job. There's years of experience that humans have accumulated that may one day, right, be codified and be encoded by AI. The day today is not that day. We're nowhere close to it. So the near-term opportunity over the next 5 to 10 years is in codifying it into what I call a cognitive ontology. I know that's a very big word, but ontology simply means, think of that as a database. An ontology has an extra thing in the database. It also describes rules and relationships among the entities in the database. And I want to tell you about the cognitive ontology, which is also more than ontology. A cognitive ontology has causal relationships in these, encoded in this, so that an AI agent can reason over it, plan, and solve problems. Meaning, what's an agent, right? An agent is something that takes a goal and plans on its own to solve that problem autonomously. So we're going from automation to autonomy, and this is something that my company does, as well as a lot of the agentic autonomy that people are trying to implement. You go from rules, right, and you add reasoning to it, okay? We're right at the edge of agents finding out how to learn, okay? A lot of the agentic deployments out there does not have the learning component yet, but you're going to hear about it over the next 6 to 12 months. And with that learning, with that adaptation, you're going to have autonomy. What is the difference between automation and autonomy? Okay? These terms both start with auto, and so sometimes people get them confused. But they are similar but very significant different in one major respect. Automation, the intelligence of the goal orientation is outside the automation, whatever it is being automated. But autonomy means you are starting with a goal. So automation is goal-oriented. Autonomy is goal-oriented. Automation is task-oriented. In terms of mindset, right, automation, knowledge management is about optimizing efficiency, okay? The mindset of autonomy is to imbue understanding, planning, and reasoning inside that system that you're building, okay? Technology, data pipeline, dashboards, many of you have built. What's coming next is reasoning agents with this cognitive ontology. And as I say, cognitive ontology is not just any database, it's database over which there's information, there's relationship that an agent can reason over. What's exciting from a business leadership point of view is that if you look at value created, right, you can estimate that the knowledge management economy gives you about 1 to 3x productivity over the lack of it, right, if the baseline is 1. But with cognitive ontology, with autonomy, because the agents are going to do a lot of the work. I'm not saying the humans are outside of it yet, right? But with the agent doing so much of the work, both in the curation of the ontology as well as the application of it, you're going to see 10 to 100x leverage. The cost of creation, that is how much money, how many dollars does it take to create one additional dollar value, right? With knowledge management, that could be about 70 cents, right? So you get maybe 30, 40%, 50% ROI on top of that. But with cognitive ontology, it's down to 10 cents to 30 cents. So you're going to get 10x gains. I need to move very quickly through this, right? So this is a conceptual diagram of what cognitive ontology is, right? The necessary ingredients to go from horizontal to vertical AI. You need facts, relations, heuristics, right? Causality, and then goals, what the agents are doing together with humans, right? Today, humans is curating all of the knowledge in your database. And if you're lucky, if you're building an agentic system with knowledge, it meant there are many agent systems built today without that knowledge base. But in the near future, you're going to see agents actively creating, curating knowledge in that ontology as well as applying it. So this gives you the gains, right? In life, in the physical world, everything is an S-curve, right? We think we're at the beginning, so we see an exponential curve, but there will be a point of saturation. Really, but the win with autonomy is that the vertical gain is going to be much greater, right? So automation gives you linear gain, that's sort of the lowest S-curve. And if you have leverage to additional insight, business intelligence, you can have a much greater gain. But you're going to get 400x, right, over 50x with cognitive ontology. But the good news with the S-curve is there are two sources of gains, okay? One source is, of course, the cognitive reuse, meaning if I codify the knowledge, how many times is it going to be reused, right? The maximum reuse is indexed at 1, 0 reuse is at 0. So as you have greater cognitive reuse, you're going to have greater gain. But you also have learning on top of that, because agents will be learning, okay? What do I mean by agent learning? Could be something as simple as an agent executing and then noticing that a website is down, or a particular task failed, so it doesn't try that again. Could be something as simple as that. Or it could be abstracting away, right, from multiple tasks and into a general rule, all autonomously. And that gain will give you this cognitive compounding zone. I want to get concrete and cover at least one use case. This is something that we do in semiconductors. How many people are in the semiconductor space here? Okay, you would think that every hand goes up here. But of course, you know, there's large semiconductor companies here. One of the processes is reactive ion etching, but you can bet that in all semiconductor processes, there's something called yield issues. And when something goes wrong, you want to do what's called ROCA, root cause analysis. So the challenge here was to sort of offset the yield loss by finding out what's wrong with the system when there's a problem. And one of the things that we do is instead of just solving that problem once, we build a cognitive ontology. In this case, experts as well as standard operating procedures, these documents are mined to find out the causal relationship. The last time that I saw oxidation, excessive oxidation on the wafer, what were the causes that were discovered, okay? And then build an ontology of all these maps, and then reason over them. And now we have agents that can autonomously, right, figure out what's wrong and doing the causal analysis. The agent perceives the real-time sensor data. It also gets information from yield and device measurements. And then essentially, if there's a problem with yield, it discovers the causes automatically. Okay, let me go through this. You can look at a slide deck later for the other use cases. I want to cover, in the time available, some of the most counterintuitive things that I have learned in doing this, both at Panasonic as well as after starting this company. Normally, many of you that are building systems, normally you focus on use cases first, right? Like, let's do one use case, let's do the next use case. And it turns out, while that is true, it can be done to a sort of the extreme, which is we have found that if we do that only one silo at a time, we miss a lot of opportunities for cross-silo knowledge. So in other words, AI is different, right? In business intelligence and other things that you can keep these data silos, but the real gains to be had is when you actually start by thinking, yes, think about one or two use cases that drive something, right? But make sure that you're also building toward this shared cognitive core, the cognitive ontology that I talk about. Okay, so let me go through this and give you this conclusion, all right? So we are at the age of adaptive autonomy, okay? So please remember the two words. Let me break it down. Adaptive means learning, okay? The agents are starting to learn, okay? And they can learn in the field, not learn in these industrial labs. And autonomy is different from automation in that autonomy agents can be goal-oriented. They will solve problem given the goals, okay? And what we want to do here is look at vertical AI and build a cognition core so that we can have compounding gains, okay? So this is where economy builds on engineering, on industrials, and so on. And even the United States, as you know, there's a big push to reindustrialize. And so I think the future is really, really exciting for those of you that are in the engineering-oriented and physically-oriented fields. Thank you.
Thank you very much, CEO, for imparting your wisdom. And please stay on the stage for the next.